Good afternoon and welcome to today's webinar hosted by Wheeland Electric and Electrical Review. My name is Eleanor Mackay and I'm the editor of Electrical Review. There is often much confusion in the workplace as to what we should and shouldn't be doing in order to fulfil our obligations to current safety legislation. In order to try and bring all of the relevant subjects together and to clarify what is required from the users and designers' perspectives, Wheeland Electric's team of safety experts will today provide an essential guide to complying with health and safety requirements when using and designing machinery. Speaking at today's webinar are Paul Considine, Global Industry Manager, Lynette Knowles, Safety Specialist, and Philip Shardlow, also a Safety Specialist. It only remains for me to hand you over to Paul Considine, who will start the presentation. Thank you, Paul.
Thank you very much, Eleanor. Hello everybody and welcome to the Wheeland webinar in conjunction with Electrical Review. As Eleanor has already said, we really want to take you through what you must do to comply with what is called the essential health and safety requirements, and that is when using or designing machinery. So the agenda for today, just one moment. Bit of a technical glitch. I can't seem to get the presentation to move on at the moment. There we go. So the agenda for today is what are the essential health and safety requirements as a first point. So we're going to give an overview of exactly what is involved in the whole process to meet the legislative requirements within the UK and the European Union. And then we're going to focus on the main point, and this is the Machinery Directive. So we're going to give an overview of the Machinery Directive. I'll explain in the first section why the Machinery Directive is so important. Following on then, we'll move into definition of the compliance process. What is the whole process you have to follow? What is the process that is laid out by the legislative requirement and the Machinery Directive? And then we're going to break it down into the components of that process, starting with risk assessment, moving on to then the design of your safety function, the implementation of it, how you verify and validate it. And at that point, we'll be introducing Euro norms. These are the standards that are available to you as an end user of a machine and a machine builder to ensure that you meet the requirements of the legislation. And we'll then move on to a part called technical files. This is where you have to compile a file to prove you've met the requirements, and ultimately CE marking is the aim. All machinery supplied after a certain date must meet the essential health and safety requirements and actually carry a CE marking to prove that. And then we'll finish with a training and competence levels that are required. There'll be an open discussion between us trying to give you an idea of what levels you need to have, and also what Wheeland can do to assist you in obtaining those levels. And for the last 10 minutes of the presentation, we have a question and answer session. So if you'd like to just put any questions you have online, and we'll try and answer those for you at the end. So moving to the first section, why do we have essential health and safety requirements? What is the reason for it? Well, it is something that we do within the European Union based on historical data that is available, and mainly the main reason is the protection of people, i.e. members of the European state, people like you and I. So if an employer or somebody is asking you to operate a machine, then this legislation is all about making sure that they provide a minimum level of protection for you when operating that machine. So the European Parliament achieved this through, to be honest, many forms of legislation, which is why it's such a confusing subject. We hope to give you an overview and a path through this today so that we can all understand it. And in the case of machinery, you know, there's a very clear requirement for this, and it is in the form of the essential health and safety requirements. There is another side to this as well, and that's also for businesses. There is a very good reason for an end user, a machine user, and the production company to implement this essential health and safety requirement, because the costs of not doing so could be very punitive to their business. There are direct costs. If you take the figures from the European Union at the moment, there is approximately 20 billion euros outstanding claim and compensation going through the various bodies for various incidents relating to machine injuries in the European Union. So that cost is something that is paid out either by the operator of the machine or their insurance company. So if it's paid out by the insurance company, then there is an increased cost in insurance for any manufacturer in their daily operating costs. Some of the indirect costs actually can be a great deal more than the direct costs. If something does go wrong and there is a court case, and a company will end up with a very hefty fine, and so it will come through in the form of a penalty. But perhaps we've already mentioned the compensation claims being rather high. I would say loss of production costs would dwarf compensation claims. Give you an example of one of our customers, a very well-known snack food brand in the European market, had an incident where somebody lost a finger. That machine, and therefore that whole production line, was closed down for a 6-week period. And if you bear in mind that they produce 80 million packets of crisps per week, that's a very big loss. And obviously loss of customers and loss of image come into that as well. I don't know how you quantify that, but that definitely has an impact too. So there are very real reasons for having this, and hopefully everyone will agree that they're good reasons to have it, and on both sides, for the individual using the machine and then the company asking them to operate it. So what are the essential health and safety requirements? Well, in the European Union they are harmonised, but here in the UK it's actually put into place in several areas, and one of which is very relevant to just the UK, but they're all legislative body and legislative work. So if we break it into two, for the workplace, for use in the workplace by the end user and the operators, there's the Health and Safety at Work Act 1974 in the UK, and then there's something called the Management of Health and Safety at Work Regulations 1999, and then the PURE regs, which is the provision and use of work equipment. These are the three areas that would be recognised by a site health and safety officer at any working plant. But he also should be aware of something called the Machinery Directive, which is what is relevant more for the machine builders, but definitely still the end users and the operators. And I hope we can show today exactly why that is the case. What we have to remember, though, that all of these work together. This is a complete process. Each part cannot be taken in isolation, and different parts of it will be used by the authorities to implement any cases and any prosecutions as well. In the UK, you will always be prosecuted under the Health and Safety at Work Act 1974, but the directive that they use to measure what you have done is the Machinery Directive. So, you have to be aware of it as a whole process. Some of them are actually the PURE regs and the Management of Health and Safety at Work regulations. They're actually what are called ACOPs, and that is an approved code of practice. So they're actually implemented for you as an operator and a factory operator to follow a set of procedures and an approved code of practice within your operating environment to ensure that you meet the regulations and the legislative requirements which are laid out by the directive, the Machinery Directive, and the Health and Safety at Work Act. So as I said, the Management of the Health and Safety at Work Regulations 1999, they're an ACOP and an approved code of practice. Now, I put this section here. This is the content section. It's only a very small part of the content section, but I want to focus on Regulation 3 because there is a general thread through this whole thing where you start and pretty much follow it through your whole procedure is risk assessment. When you are talking about operating a machine, there are risks associated in using it and operating it. Therefore, everything revolves around you doing and performing a risk assessment. And you can see that this is in the approved code of practices. And this also appears in every other section as well. So it will be, you will see in the Machinery Directive as well. But it is a common theme, and this is one of the if not the main area of focus for the machine builder and the operator. Provision and use of work equipment regulations are relating directly to equipment being installed in a factory, and they follow exactly the same procedure. They're approved codes of practice, and they are in effect identical in every case. It's the scope of each one that's different because they apply to different people. So if you're a factory operator, these are the two most important ones for your site health and safety officer. But for a machine builder, then the machinery directive is much more important. Here you can see there is actually a process flow for machinery to reach compliance. I'm going to come onto this slide later, but I want to highlight the fact that it all starts with the legal requirements. They're the essential health and safety requirements that are detailed in each and every part of those legislative documents that you've seen previously. And for a machine builder, it's the machinery directive that applies. But in order to meet that, you have to follow, and in order to meet the legal requirement, you follow the process that you see in front of you. And it all starts with risk identification, risk assessment. So I want to focus on the machinery directive because the machinery directive, the main purpose of it is to compel manufacturers to guarantee a minimum safety level, which is the essential health and safety requirements, which is what's called for in the other legislative bodies. And that's for machinery and equipment sold within the European Union. And every member state of the European Union has adopted the directive into their legal body so that it is prosecutable universally across Europe in every country. The old directive was 9837 EC, and the new one is 2006 42 EC. And this came into force as of December the 29th, 2009. And you must have complied with that from that date for any machine that you have supplied, installed, or built since that date. There is no question, there is no period of allowance where you would have been allowed to supply anything that wasn't compliant. You must comply with it from that date. As I say, the machinery directive is European law. What is not well known is that it's actually a criminal law. To not comply with the machinery directive means that you will be prosecuted under criminal law, which ultimately means that as a director of a company you could end up with a criminal record. You could end up in jail, and you know, therefore, as a director of a company, become unable to continue as a director because you're not a right and justifiable person to be a director of a company. So there's many reasons for wanting to pay attention to this. In practice, I don't think anyone's been sent to jail. But people have definitely been convicted and fined, and companies have been fined as well. I want to introduce something here as well. There are standards available. They're called Euro norms, EN numbers. If it's preceded with a BS, that means it's been adopted by the British Standards Institute, so it becomes a BSEN number. And I can tell you that here in Great Britain, we've adapted all of the European standards into the British Standards Institute. I want to clarify one point. You don't have to comply with standards. Standards are construction aids, okay? It's not compulsory. But in using standards, it's the easiest and most cost-effective way of proving that you've met the requirements of the legislation. So it's the best way to proceed, and we will be focusing later in our presentation on those standards. The ultimate aim is to CE mark your equipment. So the standards available to you take you through the whole procedure of how you're going to comply with the requirements of the European law, and therefore be able to CE mark and supply your equipment with peace of mind. The thing to remember is that you need to be reliant on what you're using as well. There are many CE marks out there that are legal and valid CE marks, but they don't necessarily allow you to comply with the European Union. So you are duty bound to check with your suppliers that they are marking it with the correct CE mark and provide you with the information that you need to make sure you complete your technical file. So basically, you should be looking at your suppliers and be sure that you've got a reputable supplier and ensuring that you get the right information from them. For instance, that CE mark you see on the right-hand side there in red, that is a legal CE marking in China. But all it means is China export. It does not mean they've tested the components to provide you with the right information that you need to complete your technical file, which we will come on to later. So what is the definition of a machine? Well, it's an assembly fitted with or intended to be fitted with a drive system other than directly applied human or animal effort, consisting of linked parts or components, at least one of which moves and are joined together for a specific application. I think that, therefore, is very broad sweeping and a very clear definition of a machine, and that you can quickly identify exactly what you need, what you are using and how you need to make sure it complies with it. One of the caveats that's been added to it now is an assembly referred to in the first indent missing only the components to connect it on site or to sources of energy and motion. And this is because people used to provide machines without that, and therefore they didn't fit the safety. Well, that's not allowed anymore. There is something now called partly completed machinery. I'm not going to spend too much time on it, but it's basically, as you can see there, something that is in effect not capable of any movement in its own right, but when connected to another component, for instance, you see here a robot arm. It cannot move in its own right. That's considered partly completed machinery. You connect that to its robot controller, and all of a sudden you've got a completed machine. Partly completed machinery is included in the directive. That means that we, as component providers, i.e. Wieland, in terms of our safety components, we have to perform exactly the same tests and provide the right information for you so that you can complete your proving that you meet the machinery directive. So we are duty bound to provide the right information and do the correct testing for you. What is the definition of a manufacturer? It means any natural or legal person who designs and or manufactures machinery or partly completed machinery covered by the directive. That means they are responsible for conformity of the machine, with a view to have been placed on the market now, whether that be under your own name or trademark, or whether you're making it for a use inside your own facility. It's irrelevant. You are asking a member of the European Union to operate that, therefore you must comply, so you are defined as a manufacturer. And also, any person who places on the market, or puts into service machinery shall be covered by this directive. That means if anybody's importing machines from outside the European, such as China, but they didn't make them themselves, but they are then selling it on into the European Union, they then are legally bound now as the manufacturer and must ensure that it complies with the legislation. Definition of placing on the market, it means making it available for the first time in the European community, whether that is for distribution or use, or whether for reward or free of charge. Basically, if you're asking a member of the European Union to operate a machine and you're installing it, or you're buying it from a third party and asking them to install it, everywhere along the chain there are people responsible for ensuring compliance. So let's move back to the flow. I said I was going to explain exactly what the process flow is. We start with a legal requirement, and in this case it's the machinery directive. These are the essential health and safety requirements. The first step we take is we do risk identification. Here is a standard available to you. It's EN 12100-1-2010, and that is detailing how to do a risk assessment, how to evaluate the risks, and how to apply risk reduction measures. If the risk is so high that risk reduction measures are needed, you then have to look at the safety function about how you're going to protect from that risk. Now, the first step would be a fixed guard, but if you then need to go on and design control systems, then you're designing a safety function. And my colleague Phil is going to talk later about the process of designing the safety function. He will then show you how to implement the design in terms of all of the components that are needed to be considered when designing a system, what you need to do in terms of testing, and this is the verification and the validation process. So Phil will talk you through that, and Lynette will then further on in the presentation talk to you about documentation and compliance and ultimately CE marking.
Can we ask the first polling question, please?
Okay, thank you very much. Okay, the first poll question is coming up for you now, and that is, do you need further information on legislation? And please select one of the following options: yes, no, or possibly. And we'll give you a few seconds to answer that, and we will close the poll and move back to the presentation. Thank you. Back over to you.
Okay, thank you very much, everybody. So you can see there is a whole process that you have to follow here, but it starts with the legal requirement, and your first step is always risk identification. You have to do a risk assessment. Where does risk assessment stand in this? I mentioned standards. This is the hierarchy of European standards that is available to you, and they're split into 3 levels. There's Type A standards, B standards, and C standards. Type A standards are where you lay out the basic safety standards. And you can see there the main one for machine building is 12100-1 and Part 2 for validation. And 12100 is where you have the whole process of risk assessment detailed for you. It also details risk reduction and the basic principles of design. So this is where you start to apply your risk assessment in terms of, do I need risk reduction measures? If I do, then what is the basic principles of design? B standards are split into 2. There are B1 standards and there are B2 standards. I'll start with B2 standards because B2 standards are construction standards. They are standards that are laid out for components that you may use in a safety system and how they should be constructed. So you will see there 13850 is an emergency stop standard. It tells you how to construct and how to actually use an emergency stop. And then you also have 574, which is for a 2-hand control device. It tells you how to construct it and how you should be using it and how you integrate it into your design. B1 standards are validation standards. So they are relating to, and you'll see that we have there 60204. That is the standard that relates to the safety of electrical equipment relating to machines and in a control cabinet. So that tells you how to construct your electrical circuit safely and your panel safety. 13849 is a newish standard, and this is the new standard for validation. This standard tells you how to validate your system, your design. And my colleague Phil Shardlow is going to talk you through that later. Something at the bottom there is C standards. C standards are king. If you manufacture a machine that has got a C standard related to it, then you must use the C standard in the construction of and validation of your machine. And that is harmonized with the new requirements. They are all harmonized now, so you will use a C standard, and that will tell you step by step how to design and validate your machine. But C standards are laid out because there are certain machines within the market that have very specific functional and therefore safety requirements. Hopefully you can see that there. Mechanical presses are very dangerous. They're one of the highest risk machines on the market, so they have their own very special standards. Elevators is another one, and injection molding machines too, because they're basically fundamentally a press as well. But there are others. There's robots, etc. You can see them for yourself. If anybody wants a list of standards, it is available on the European website, or Wieland can help you and provide you with that document. Just express your interest to us afterwards and we'll help you out. So risk assessment. Risk assessment now is no longer building the machine and then looking at it and saying, oh, what's dangerous about it? You have to do it for the whole life cycle of the machine. So it's now a new probabilistic approach. So you've got to determine the limits of the machine and its intended use and any reasonably foreseeable misuse, and identify hazards and hazardous situations for the whole life cycle of the machine. That means building it, transporting it, assembling it, what happens in normal use, what happens during maintenance procedures, and also disposal. You have to estimate the risks for each and every danger that you see in each and every one of those cycle areas. You have to then actually assess the severity of the injury, the probability of occurrence, and you have to evaluate the risk. Is the risk high enough that risk reduction is required? If yes, then you have to eliminate the hazard or reduce that risk and that hazard by application of protective measures. Even now, Wieland don't come into this because you have got a fixed guard as your first point of call. Only when you go into using a safety circuit where you need to actually apply control measures do we start getting involved in the process. But the intention is to do the risk assessment up front through analysis, assessment, and then implementing the basic principles of design. Then you go into manufacturing and designing and manufacturing your machine and CE marking it. In the past, where it's gone wrong is you manufacture the machine first, you then do the risk assessment, and you end up re-engineering the machine. So hopefully this process should make it a lower cost for anybody making the machine. So you can see here quite clearly there is a process flow laid out in the standards for you to follow. I've already talked you through the aspects of this. So there's a risk assessment and evaluation, and if risk reduction is needed, you can see there the standard quite clearly shows you the process and decision-making process for you. It's not just for mechanical hazards that you might imagine, such as cutting, catching, shearing, crushing. You have to take into account many things, and you can see a list there. Electrical, thermal, noise, vibration, radiation, hazardous substances, ergonomics, and a combination of several other factors in the work environment. Confined spaces, is there going to be a gas issue where people will become overcome by it? There are many things you need to consider, not just the mechanical elements. Something interesting now, I want to tie this in. This isn't just for machine builders, this is for end users as well. So if you as a factory operating environment buy, say, 3 machines from different sources and you bring them into your facility and you install them yourself and connect them yourself, you have to take into account something called continuous plant. If it's proven to be continuous plant because there's a functional or mechanical control or electrical control link between the machines, then that then becomes considered a single machine in its own right, and you have to do a new risk assessment to see if any additional dangers have been brought into play, and if they have, you have to design a safety system to allow for that as well. So it's not just about single machine builders, it's end users and operators who bring machines together for a specific function and a process line. You are covered as well. So we hope to prove to you by the end of this presentation that it's not just machine builders, it's the end user, the installer, that has to take things into account as well.
Can we ask the second polling question, please?
Thank you very much, Paul. So our second poll question is, do you understand the risk assessment process? Please select from yes, no, or some understanding, but I need further clarification. I'll give you a few seconds to answer that. We'll be closing that poll now. Thank you. Back over to you.
Thank you very much. I'd now like to hand over to my colleague Phil Shardlow, who, as I previously mentioned, will talk you through how to design a safety function, implement verification and validation process, and he will talk you through the relevant Euro norms as part of that process. Over to you, Phil.
Thanks very much, Paul. Good afternoon, everyone. You can see on the screen there the hierarchy of standards that Paul already presented. We've put it up there again just to highlight the fact that the standard that most people are following at the moment is EN ISO 13849, and that sits in there as a B1 standard, which is a generic safety standard dealing with one safety aspect. As Paul's mentioned, there are several C standards. In fact, there are over 500 different C standards out there, and if there's a C standard relevant to your machine, then you should certainly be looking at using that one. If there isn't, then you use a B or an A standard as applicable. A few years ago, the standard that most people were following for risk assessment, etc., was the old EN 954-1, which was all fine, but EN 954 didn't account for reliability in any system, and it also didn't account for some of the new equipment that was out there, which had software included in it. So there was a need to replace EN 954, and it was replaced by 2 standards, EN ISO 13849-1 being one of them, and the other one being IEC 62061, which I'll touch on briefly. The main standard people use at the moment is 13849, and that's because it covers all aspects such as electrical, mechanical, pneumatics, hydraulics, whereas 62061 covers purely electrical. There are cases for using either can be used. Both systems use what's called PFH, but there are subtle differences between the two. We're going to focus for the next 5 or 10 minutes on 13849 specifically. And if I can just go back a slide. Oh, sorry. And if we tend to use this graph as part of the risk assessment, the first step in system design, in safety system design, is to determine which level of risk of performance you need to achieve. So many of you have probably seen a graph similar to this, or this graph itself. If I just take you through a fairly straightforward example, So I have a machine, and it's, for example, a mixing machine with some rotating blades, rotating at quite a fast speed, and I need to identify what level of safety I need to achieve for this machine. So the first thing I need to ascertain is what kind of injury, what level of injury would happen if I was to access this hazard. In this case, I would suggest it would be quite a serious injury, a non-reversible injury, such as a loss of a limb. So I would go down the road of F2. The next thing I'd look at would be the exposure to that hazard, whether it be not very often or frequent. And the definition generally for seldom and frequent is if you access the area more than once an hour, that's considered to be quite frequent. So in this case, we'll say it's seldom, so we'll go up to F1. And then the next thing we need to ascertain is it possible to avoid the hazard? And by that I mean if the machine's moving fast, and my hand is caught in the hazardous area, am I able to get my hand out before the accident happens? If it's moving slowly, then clearly you may be able to avoid what's going to happen. In this case, we'll say it's a P2 and it's scarcely possible because the blades might be moving relatively fast while it's mixing. So if you follow that through, you would then end up at a performance level required of D, and that level D is what we're looking to achieve at the end of our design. So that's the first point we need to know. Okay, cool, thanks. Now, the graph in front of you there is for EN IEC 62061, and it's referring to the other standard, which rather than using performance levels, uses what are called SIL levels, safety integrity levels. Now, the process for 62061, certainly in this part of it, is not entirely different. It's still looking at the frequency of a dangerous event, the probability, and the chance of avoidance. But you get a safety integrity level rather than a performance level. The two things are not don't correlate directly, i.e. still one isn't the same as performance level A, etc. But they're the same in terms of the fact that they're a hierarchical. But we're going to concentrate on 13849 in this case, because it includes mechanical, pneumatics, and hydraulics. And there is talk currently that the two standards will be harmonised into one main standard because so many people are using 13849. Okay. So, whereas in the old EN 954, only the first four things on the list you can see in front of you were really applicable. Now in 13849, there are more factors to consider. For example, severity of injury, frequency and exposure, and the possibility of avoiding a hazard, which we've already discussed from the risk graph, are all obviously still there. Also, there's the architectural category, what's called diagnostic coverage. I'll go into a little bit of detail on these as we go through. Common cause failures, mean time to dangerous failure, safety-related software, systematic failure, and environmental conditions. All these factors need to be taken into account when designing the system. So the procedure to comply with BSEN ISO 13849-1, and in turn for you to comply with the machinery directive, or to help you comply with the machinery directive, the procedure is firstly to identify the hazards on the machine, as Paul's already spoken about earlier, using EN 12100. Assess the risk parameters in accordance with Annex A of the machinery directive. You then need to determine the required performance level, which we just discussed. In our example, it came out as a level D. Then we need to design and implement the required safety functions in order to achieve that level. Determine the performance level considering the things on the list before, for example, mean time to dangerous failure, common cause failure, diagnostic coverage, and the category of the safety-related parts. And then when you've done the design, you need to then compare the performance level with the required performance level that you stated at the start. We'll go into a little bit more detail on that shortly. And then after you've done that, you have to validate whether all the requirements have been met. So before in EN954, you didn't have to do any of that. You didn't have to do any validation or any proving. You did your system, and that was the end of it. Now you've got to say what you need, say what performance level you need to achieve, design it, and then prove you've done it, and prove you achieved it. So in a little bit more detail, one or two of the acronyms that were on there as to what they are. The first one is the mean time to dangerous failure. The MTTF assumes the fact that every system will fail if you just wait long enough, which is probably true. And that the probability of a constant failure rate item having a life exceeding its MTTF is only 37%. Paul, do you know where those figures come from?
These are documented and done by the European Union and Parliament.
All right, okay.
And there is a committee that compiles this information statistically. Basically here what they're saying is 63% of items will fail before they reach the mean time to dangerous failure, but 37% will fail dangerously. So this part of the standard is actually asking you to design and to qualify the components that you're using, to make sure that they're safe enough for the level of risk, i.e. how reliable are they?
Okay, thank you. So the MTTFE is calculated for each channel because you've got two separate. If you've got two separate channels in your system, then it needs to be calculated for each one, and there's a limit of 100 years. The other thing you need to also bear in mind when looking at the MTTFE is the number of operations. If it's a switch that's only being used once a day, then clearly that's different from something that's been operated every few seconds. And it's split into three categories, as you can see there: low, 3 up to 10 years; medium, range from 10 up to 30; and then high, 30 up to 100. Anything above 100 is still classed in the high category. Okay. Common cause failure. This describes the failure of the control system of redundant design which are attributable to a common cause. Obviously only relevant to a system that's got two channels. And the standard provides a points-based method for the assessment of the measurements of CCF. This method has also been implemented in Systema, and I'll talk about Systema briefly shortly. It's basically a validation tool that helps you to validate your safe system. On the slide, technical hitch here. Okay. Again, the diagnostic coverage is basically a measurement of the ability of the system to detect dangerous faults in relation to the number of faults it has. Annex C of the standard contains the diagnostic coverage values of typical test methods, and it divides it into 4 classes. So really what this is the system's ability to detect any faults within itself. So the four categories are none, you get a value of up to 60%, low 60 to 90, medium 90 to 99, and high 99 and above. And it helps if we skip go forward a slide, please, Paul. Thank you. Before you can see the different architectures of wireless safety system. Category 1 and 2, you can see the occurrence of a fault can cause the loss of the safety function between test intervals. So if you had a system that was category 1 or 2, you've got relatively low diagnostic coverage. You've got not a great ability to detect any faults. If you go to the next system, which is a dual channel system, a category 3 system, if a fault occurred in the system, the safety function will always remain intact, but some faults may not be detected. And if there's more than one fault or an accumulation of faults, this can cause the loss of the safety function. So you've got a higher diagnostic coverage because you're able to capture faults and remain safe. But if you go then to a category 4 system, if a single fault occurs, the safety function always remains intact, and the faults are detected at the proper time to prevent the loss of the safety function. So this links back to diagnostic coverage, and when you're working with Systema, you get a value diagnostic coverage, which then you can use to validate your system. Okay, cool. Okay, this is where it all comes together. So if you take an example, if you take the second category 2 column, the one that's sort of slap bang in the middle of that diagram, here we have a category 2 system with diagnostic coverage of medium, and you can see the bar there indicates to us that we can gain as much as a performance level D, but also it can be down as far as performance level A. Now, if our performance level requirement was E, then we can see here we'd need to change our architecture to a category 4, and our diagnostic coverage obviously high, and also make sure we're using the correct components in order to achieve that. But this is a quick look at a quick sort of retina as to where what we need to achieve. Paul, you need to answer that slide because I'm very okay. Okay, the next slide. Okay, the last slide in my section here is just a quick mention of the Systema calculation tool. This is available to anyone and everybody. It's free download off the IFA website. And what it does, it brings all of the previously mentioned items together and allows you to verify and validate your system. And that it also produces a report which can then go into your technical file to show that you've done all you needed to do with your safety system. We at Wieland are all fully trained in the use of Systema, and are more than happy to help and support anybody with the use of it. But it's certainly worthwhile understanding the benefits of using the tool. You can do your verification without the tool, but the calculations are quite long-winded, and these days the software is very easy to use. And as I say, Wieland will support anybody who wants to seek further assistance with it. I think you can have a polling question, I think, please.
Okay, thank you very much. And the next poll question is, do you use performance levels or safety integrity levels? Please select one of the following. Yes, no, in some capacity, but I need further clarification. I'll give you a few seconds to answer that. And we'll be closing that poll now, and back over to you.
Okay, thank you. I'm going to now hand you over to my colleague Lynette Knowles, who's going to talk you through the technical file and the CE marking part of the process. Thank you.
Thank you, Phil, and thank you, Paul, for going through that. I'm now going to talk to you about the importance of the technical file with a brief overview of the CE marking process and why it's very important to correlate all the information given for the process of the technical file, including the documentation and the compliance towards CE marking, thus completing the flow process that Paul went through earlier. Firstly, it's important to understand that before placing machinery on the market and or putting it into service, the manufacturer or its authorised representative must be able to assemble comprehensive information covering the designs, the calculations, construction and conformity assessment and use of the product to demonstrate how their machine complies with the applicable directives and is safe during all phases of its life cycle. So why and how is this done? Well, firstly we want to look at making sure that we comply to the relevant health and safety requirements as set out in Annex 1 that Paul went through. Then we look at the technical file, which is detailed out in Annex 7, Part A, which you have to make available for it. This comprises of a construction file showing all the relevant calculations and tools that you've used to put it through, any references and the mention of standards used or followed to go through with it. And this particular file has to be made available for 10 years following the date of manufacture. Then you need to provide the necessary information such as the operating and assembly instructions. Some of the main changes and stricter requirements concerning the operator and user manual. Firstly, the language of the country in which the machine is to be used. It should be completed in that. You've got your EC declaration of conformity. Any information about residual risks that may remain have to be included in it. Any instructions on the protective measures that have to be taken by the user. Assembly, installation and connection instructions, and this also includes any drawings or additional diagrams. A comprehensive instruction set for putting the machine into service. And also any operating methods that you need in the event of an accident or breakdown of the machine that need to be followed. Specification of spare parts, because if you use or change any of the products, you could be creating new risks and invalidate your design. And all sales brochures have to correspond to the manual. There is a slight difference on the technical file because for partly completed machinery, which is part B of Annex 7, which Paul mentioned earlier. Basically, the machinery must not be put in service until the machine into which it is to be incorporated has been shown to conform to the provisions of the directive. So in partially completed machinery, you can't issue any certificate on there. So here to cover that, you use an EC declaration of incorporation instead of the EC declaration of conformity, which you use for complete machinery in the technical file. Assembly instructions need to be in the official community language and put down on there. And this is less cost. When you're doing partially completed machinery, it's actually less cost for the translation compared to the complete machines. And as Paul mentioned, we ourselves as a manufacturer also have to comply and ensure that we can provide you with all the information and product calculations, etc. you need to complete your technical file. Then moving on very, very quickly to sort of CE marking. CE marking, or formerly known as EC mark, is a mandatory conformity making for certain products sold within the European market. Basically, it's a responsibility of the person who places the product or the machine on the market or places it into service. And it also includes those who import non-CE market equipment into Europe. That's a very important fact, perhaps for machines that may be coming out from America into Europe and that side of it. But it is also important to note that the CE mark is not a quality mark, and nor is it a guarantee that the product meets all the requirements of the relevant EU product and safety law. It's just a guide to say, as part of your technical file, that you've followed through to go on there. It's your responsibility of the buyer of the machine to check and find out that you comply. So typically what you'd have on a CE plate as an example would be year of manufacture, the type of the machine that it is, any serial number, ident number, and you also have to clearly put on there the manufacturer's name and address and where the required authorised representative's name and address on there too, to go through in relevance to the standards. Now that is just a brief guide to the CE marking. There are other steps on there, and as we mentioned, we're more than happy to come in and discuss further with you.
We have the polling question, please.
Okay, great, thank you. So the next poll question is your technical file available? And a simple selection between yes and no, please. We'll give you a few seconds to open that. Thank you very much. Back over to you.
Thank you very much, Helena. This is Paul Considine again. I just want to talk, as I said at the beginning, we'll have an open discussion here about training and competence. What does it mean? What do you have to know to be able to do this? Well, the big thing about the Machinery Directive is that it allows you to self-certify, to self-validate and do your own technical files. only machines that are listed under Clause 4 have to be submitted to a notified body for approval and the proof of their documentation. And these things are such things as power presses or woodworking machinery, or certain types of woodworking machinery anyway. They're all listed under Clause 4, but this is something you can do yourselves. So what training do you need? Well, it's quite open, to be honest, in the fact that they say a competent person. What does it mean? Well, a competent person is somebody really that is judged to be qualified enough to understand the procedures. So an engineer is definitely going to be somebody that would be considered as a competent person. So you have, though, in this law, ignorance is no defense. You have to know about it. As a competent person, it is your duty to train yourself and know this. So you have to be able to, you have to make some effort to go and find out about it. We as Wieland are here saying that we're in a position where we can help you do that. There's lots of sources of information that you can have, and we can point you in the right direction and provide you with all the right information that you need. So if you want to contact us for further training directly from us or other points of reference, then please feel free to contact us, and we'd be glad to help. But here on this slide, though, you can see some of the things that are available. We're willing to give you a tool if you want to contact us called the CAN report, which is actually a copy of this new machinery directive, but it's a tool. It's laid out in a manner where you can see the changes, and it tells you what you're required to do, and we can guide you through that. IFA is the German Health and Safety Executive. I want to clarify one point. The IFA administers the Systema software on behalf of the European Union. It's free software. You can download it free of charge. You can see the link right there to do so. And they also offer there on that website reports and support tools for you for the application of the standard 13849 to prove compliance. And also Wieland offer you software and tools as well. Something that we didn't mention today is we work in conjunction with a company called DocuFi. And DocuFi produce a software package that is a risk assessment package. So it takes you through step by step exactly what you need to do a risk assessment as well. So hopefully Wieland can prove that we are a competent supply partner and we can support you. And basically, if you wish to contact us, please do so, and we'll be glad to help. So now we come to the question and answers session. So we've had one or two questions polled. I don't know if anybody else has got any they wish to submit now, and we'll answer them for you. But the first question I have is, do I have to have my technical file compiled and stored in a single place? The answer to that is no, you don't. You have to be able to access the information and the parts of your technical file easily. And in the event of an incident, for instance, it depends on the type of incident, but if it's a very dangerous one, a fatal incident, the Health and Safety Executive will expect you to provide that technical file within a very short period of time, I think 24 hours. For a lesser incident, then I think the time period is longer, but you should be able to access it easily. Wieland would recommend that you use the DocuFi tool and the Systema tool as a coordination point. They're both very powerful tools, and you can use them to coordinate your technical file compilation very effectively, and they will be able to pull everything together in a single place.
The second question that came through was how do I document my risk assessment?
How do I document my risk assessment? Well, that's a very open question, to be honest with you, because a risk assessment, it depends on the type of machine and the complexity of the issue and the number of factors you have to take into account. But it can be a single-page document all the way through to a multi-page document. The DocuFi software that we mentioned actually will take you through step-by-step guide, and the DocuFi software can also help you compile your technical file way beyond your risk assessment. But a risk assessment, you could have a single page if the machine is simple enough. You have to look at the complexity and the issues that you're dealing with, and then the standard will guide you on the amount of detail you need to go into.
Another question, and I've been asked this question before that's come up, is what happens if I'm upgrading the machine? If I'm a contractor and I've been asked to come in and upgrade a machine, and I don't have access to the original risk assessment document.
So what happens if I'm upgrading a machine? and I don't have access to the risk assessment. Well, let's answer that question first, but that one prompts another one for me as well. Basically, what happens if I'm upgrading a machine and I don't have a risk assessment? Well, you have to perform a full risk assessment yourself before you undertake any work on it and any upgrade work. So that's without question. The other question that comes out of that for me is, what happens if I'm upgrading a machine? Well, one thing we didn't mention actually was that this directive is not retrospective in terms of you don't have to do it with existing plant and machinery and upgrade everything you've got. Or you don't, sorry, let me rephrase that. You don't have to retrospectively make sure everything's compliant. But if you upgrade a machine, you have to follow the process. And you have to do a risk assessment and see if that upgrade affects the performance of the machine, and therefore you have to do a risk assessment to check if your existing safety system is man enough to actually cope with the increased performance of the machine. And if it is not, then you have to go through the whole process of redesigning the safety function and validating it to the new directive and standards.
That's a good answer. And the last one that's come through is, how do the HSE prosecute in the case of an incident? What's the procedure, I guess the question is?
Well, it always starts with a site visit and an inspection from the health and safety officer, and then any parties involved in it will be called in and asked to present their case, and then a full inspection will be done. But in the UK, you will always be prosecuted under Health and Safety at Work Act 1974. It is a criminal prosecution, as I mentioned earlier, and it will go through to the courts if necessary. But they will use the Machinery Directive to measure what you have done, what measures you did in terms of your design, to see if you have covered yourself. We have to remember this is actually always ends up, forgive me for using this term, but it's a bit of an arse covering exercise really, because when it goes to court, there's a lot of lawyers get involved from all different parties, and those lawyers will be looking to apportion blame elsewhere to avoid their client from accepting any blame. So really, as a machine builder and an operator and an end user of a machine, you really need to follow this process to cover yourself, because if you cannot prove what measures you've taken, you're leaving yourself very liable to all sorts of prosecutions and obviously costs involved in this as well. So if you follow this procedure that we've described today, you can be pretty confident that you've taken the measures that are necessary, and your liability will be much, much reduced.
Yeah, I think just to reiterate the point that Paul made earlier, the standards are there to help you do that. And if during your process you follow the standards, the relevant standards, and you're going a long way to being able to support your case, I think it's a really important point. I think that's all the questions we have. So can we hand back to Electrical Review?
Yes, thank you very much. And we'll just go to one last poll question, please, which is, how useful was this webinar in aiding your machine building project? So we've got very useful, not very useful, or somewhat useful. So my thanks go to Paul, Lynette and Phil for a very informative presentation. A Windows Media file of the webinar will be available to view on demand, and further information will be found at www.electricalreview.co.uk. It only remains for me to thank you for attending today's webinar. Thank you very much. Goodbye.